Good morning, YouTube. Today we're going to be talking about phasing gate drive transformers, or they're called GDTs in the DR world, and why it's important because of your switching on your IGBTs. So basically, the layout here is from left to right when you're facing a full bridge system, which we're going to be looking at that on the QCW full bridge, and I'm going to show you guys how to phase it with an oscilloscope as well, and checking continuity on your GDT, so you don't have any open gates that'll basically shoot them open and kill the capacitance on them. But let's start over here. So when you're phasing your gate drive transformers from your driver, you usually have two GDT outputs. With a half bridge system and a standard OCD full bridge system, you're only going to need one gate drive output. So that's your positive and negative on G1 for gate drive 1. You're going to have gate drive 2, which is G2, positive and negative, usually. And for your IGBTs, that's going to be at the switches themselves. You're going to have gate 1, emitter 1, gate 2, emitter 2 on each IGBT. So you're going to have two half bridges in one IGBT, basically. So IGBT2, if you're using a full bridge system, then you're going to have gate 1, emitter 1, gate 2, emitter 2 on your second IGBT as well. So we're going to be covering a half bridge system. With your GDT, usually you have 3 wires. One wire is wrapped around, or they're all wrapped around the GDT, but one wire goes to your positive and negative on the GDT output from your driver, which I'll show you guys that on the full bridge system. IGBT1 on your gate and emitter 1, you're going to have one wire connecting to those two inputs. And same with gate 2 and emitter 2. You're going to have one other wire that has two outputs connected to those. And that's where your phasing happens at G1 and E1, which is separate from G2 and E2 for a half bridge. Now for a full bridge, you're going to have 5 wires. One wire is going to this GDT output. So that's 1. And then you have 2. The second one going to G1, E1, the third one going to G2, E2, the fourth one going to the second IGBT at G1, E1, and the fifth one going to G2 and E2. So those all have to be phased if you're running a full bridge system. So with that being said, on the phasing, how do you want these phased? Well, IGBT1, G1, and E1, your gate 1 is going to be turned on, while G2 is going to be turned off, because they have to be diametrically opposed to one another. When gate 1 and gate 2 are switching, gate 2 has to be shut off while gate 1's turning on. So on IGBT2, gate 1 and IGBT2, gate 2, these are going to be diametrically opposed from IGBT1, as well as out of phase with them too. So IGBT2, gate 1 is going to be shutting off, while IGBT2, gate 2 is going to be turning on. So gate 2 from IGBT2 and gate 2 at IGBT1 are diametrically opposed from one another as well. The first IGBT is switching off on gate 2, and the second IGBT, gate 2, is switching on. So that's how you want it. Now usually with freewheeling, you're going to have 2 separate GDTs wound in a half bridge configuration with 3 wires. And those are going to each IGBT. Hence, you still see that the on, off, off, on still applies. Now, if you were to use 2 IGBTs with a standard OCD system, that means a standard driver. If you're using 2 GDTs, then they're going to be wound in half bridge configuration. That's going to be switching from on, off, not on, off, on. That only applies to the OCD for on, off, if you have 2 GDTs in a half bridge configuration. Now, freewheeling and standard configuration GDTs, where you're using one GDT to run a full bridge system, that's going to apply with the on, off, on. And same with your freewheeling running 2 GDTs. It's on, off, on. As I said before, I really want to stress this. If you're using 2 GDTs with a standard OCD, you're switching from IGBT1 is going to be on off, and then you're switching from IGBT2 is going to be on off, not off on. That's only for the standard OCD. So I just really want to make that point. So we're going to go over to the QCW full bridge system, and I'm going to give you guys an overview on how to phase the gates with an oscilloscope. So let's go over there real quick. All right, so as I was explaining, with the full bridge system and with your GDT, I want to make a note of this. I really do, because I actually blew the bridge in this because I did not check continuity with my color connections. When you wind your color connections, which here's your power wire, I just want to make that mention. That's your one wire, 2, 3, 4, 5, since it's a full bridge system. You're going to have two separate colors. Now, before you even think about phasing these to the gates, you have to check continuity with these two connections right here with your colors. Each color, you want to make sure that each end of this has continuity per every two connections. So the black and red have to have continuity on one color. And what I did accidentally was I wound this open end to this yellow open end. So they all were wound open, and I blew each half bridge in this IGBT, meaning one side of the bridge in each transistor. So with that being said, always make sure to measure your continuity. Now, when you're checking your switching on your phase, you can basically connect your positive and negative, or swap polarity from your negative to your positive to check if and see if it's switching on or off. And right here, since this has already been gone through, continuity's been checked and the GDT's been fixed. I'm waiting on transistors. I'm going to show you guys how to connect your scope. You're going to connect your scope to the back of the outputs right there at your gates. And using your interrupter, just turn on a small pulse width to where the GDT is switching on. Then you can hear it, and there's your on function right there. So gate 1, emitter 1 of IGBT1, or actually it's gate 2, emitter 2. It doesn't really matter on the labeling as long as you go across from left to right. So the first set of gates, that's how we're going to label it. That's switching on. So as we said, we want the bridge to switch on. So on, off, off, on. And I'm going to show you guys how to check that, see if you're switching on or off. You can take these off before you even connect them to the bridge and put your positive and your negative on each end of the IGBT leads, or the GDT leads, I'm sorry. And that's how you check it. So we're going to reverse polarity, and all you do to switch it off before you connect them to your gate drive boards is you just switch polarity with the scope to see if it's switching off. Now, whichever one is positive, so if you want the gates to switch on, then you're going to put the positive where your lead is from your oscilloscope on that wire, and whichever one is positive, you're going to connect it to your gate for switching on. Your negative is going to go on your emitter for positive. Now, for negative or off switching, you're going to connect your negative lead to your gate and your positive on the emitter. So that's going to be switching off, which I'll show you guys just by switching those connections on your oscilloscope. So I'll do that real quick and give you guys an example of what off switching looks like. So this is on switching, and I'll show you what off switching looks like just by switching the polarity on the oscilloscope leads. And that's what off looks like on the GDT phase. So going across, you want on, off, off, on. And this right here, the first indicator, if it's pointing up like it was, that's on. If it's pointing down, then that's off. And that's how you phase your GDT for a full bridge for switching. So I hope this video helped you guys out, and hope to see you guys around, and thanks for tuning in.